Hello everyone, and a warm welcome to today's webinar. My name is Michael Zapp and I will be your host. This webinar is part of our SICAM 8 series, and today we are providing you more details of our SICAM A8000 family, a very important component of the SICAM 8 hardware and host of the SICAM 8 software applications. Let's have a short look on the agenda. We will start with a short recap of the SICAM 8 platform approach. Then we will show you the hardware structure and functionality of our SICAM A8000 RTUs and inform you, of course, about new components and functions. But the main part is to show you the workflow of our CP8050 configuration using an example project that reflects to the title of this webinar, SICAM A8000, What's New, and my first CP8050 project. We had this topic already covered 2.5 years back, and we are showing you today the new features, functions, and usability improvements of our CP8050 RTU, and of course also of the SICAM 8 engineering tool, SICAM Device Manager. At the end, I will make a summary of the presentation and the workflow, and as always, we are open our stage to answer your questions. I said we, because today I'm here in a double function. Additionally to my role as host, I will also be one of the presenters. But I'm not alone. My colleague Jorge Diaz is with me. Jorge, please join me at stage. Jorge and I am in the promoter team for our SICAM 8 portfolio. I am a technical consultant and Jorge is our application specialist. Please note that you will not be able to post your questions directly during the presentation. However, we already invite you to insert your question in the question box located at the top right of the window once you exit the full screen mode by pressing the escape button. Your questions will be addressed after our presentation during the concluding question and answer session. Furthermore, of course, you will have access to the on-demand recording right after the session. Okay, that's it regarding the technicalities. Now, let us get started. Some of you may attended our SICAM 8 unboxing event and the first sessions where we introduced in detail the concept, the components and software applications of our SICAM 8 Power Automation platform. In case you missed these sessions, and additionally, as a recap, let me start with a short abstract before Jorge and I am presenting you the news of our SICAM A8000 family and the configuration workflow of our CP8050 RTU. What was the reason of extending our proven SICAM A8000 family into a platform concept, namely the SICAM 8 Power Automation platform? Coming from the way the energy generation distribution is changing since years, and the impact this is having to the projects what need to be realized, it ends up in need for speed. How can this be reached? The key is separation and modularity. The SICAM 8 Power Automation platform can be seen as a toolkit or a construction set and is able to tidily connect the SICAM 8 software, but not only with the SICAM 8 hardware like our CP8050, what will be the focus of today's webinar, but also with third-party industrial PCs. The clue for this connection is handled by the so-called SICAM 8 core. The focus of today's webinar is not only to give you some general information and news of the SICAM 8 A8000 family, especially for the Linux-based CP8050 and CP8031, an essential part of the SICAM 8 hardware, but Jorge will show you how easy and efficient you can engineer the hardware and the SICAM 8 applications with our SICAM Device Manager, the engineering tool for SICAM 8. Our A8000 family is already designed in the architecture to be modular and scalable regarding the hardware components. Based on that, we are scaling further, not only hardware-wise anymore, but software-wise as well. We offer our customers a platform where applications can run on the existing A8000 hardware, but also on third-party industrial PCs, if even more performance is required. You already know our SICAM A8000 RTUs. There are basically two family branches. One is made by the small CP8000, CP8021 and CP8022, which are wonderful devices on their own, right? However, for more demanding applications where maximum performance and the highest cybersecurity requirements are paramount, the Linux-based RTUs have the best toolset available. Now, the smaller RTUs will not be part of our platform SICAM 8. Instead, the wonderful properties of the Linux-based CP8050 and CP8031 RTUs are the basis of the new platform. The SICAM A8000 Linux-based RTUs run on a hardware which fulfill already demanding requirements. On this hardware, the SICAM 8 software is running. This solution gives the RTU the capability to fulfill a wide range of demanding technical requirements, advanced automation functions, highest cybersecurity features, multiple communication protocols, and the possibility to host user-defined applications, also known as CApps. The SICAM A8000 RTUs, while very powerful, are still constrained by the supplied hardware, like processor power and the size of available RAMs. Well, with the new SICAM 8 platform, the SICAM 8 software can be installed also on third-party industrial PC hardware, with more processor performance and more RAM, allowing to install even extremely large applications. When installing the SICAM 8 software on a third-party industrial PC, it's called SICAM 8 software solution. All that you need is that this PC is equipped with a compatible operating system such as Linux Debian. As promised, I keep the recap of SICAM 8 Power Automation platform short. I'm coming now to the focus topics of today's webinar, our wonderful SICAM A8000 RTU family, that can be seen as the base and the strong fundament of the SICAM 8 platform. Let me start with the structure and modular concept of the smaller A8000 RTUs, namely our CP8000, CP8021, and CP8022. Common to all small SICAM RTUs is they are using the same operating system. It's not Linux, but that is the reason why they are not part of the SICAM 8 platform. And not only the same operating system, they're using the same firmware and the same applications can be installed. All of them are providing 4 communication interfaces, 2 Ethernet-based and 2 serial interfaces, one RS-232 and one RS-485 interface. The CP8022 has additional 1 GPRS interface and 1 additional serial interface, what can be configured either as RS-232 or as RS-485 interface. Up to 4 communication protocols can be loaded, and it is possible to connect up to 8 input-output modules. As the CP8000 already has 2 internal input-output modules equipped, there are only up to 6 additional external I/O modules what can be connected. The CP8000 as compact RTU has the power supply already internally equipped and no redundant power supply can be connected. But for the CP8021 and CP8022, you can select 1 or also 2 power supplies in case redundant power supplies are requested. Depending on the available auxiliary voltage and output power, we have for the range between 24 and 60 volt, our PS8620 and 8640, and for the range of 110 and to 220 volt DC, and additionally AC 100 to 240 volt, our power supply 8622 and 8642. There is a range of input-output modules what can be selected and connected to the RTUs, up to 8 modules for the CP8021 and also for the CP8022, and up to 6 modules to the CP8000. And there you need a connector module, a connector module 808011. The LED module is not counting to these limits and is covering the indications for these 8 input-output modules. The following types of SICAM input-output modules are available. I have digital input modules, DI811X. X means depending on the used auxiliary voltage of the indication circuit. I have digital output modules with relay contacts, DO8212. Analog input modules with inputs either for temperature sensors, then it's AE8310, or for transducer inputs from plus minus 20 milliamp, or alternatively plus minus 10 volt, that is analog input module 8320. But it's also possible to have a CT-VT direct connection using low power standard covered by the AE 8510 and 8511. And finally, also we can equip the LTUs with analog output module from plus minus 20 milliamp or plus minus 10 volt. That is the IE8330. That is covering the architecture and the hardware modularity of our smaller A8000 LTUs. They are an important member of our SICAM A8000 family, even if they are not member of the SICAM 8 platform. But also there, we have some new functionalities and hardware available. The new CP8022 hardware is now equipped with a modern LTE communication, what is having also a GPRS backup. And this new hardware for the CP8022 has been released end of April this year. Of course, we are planning to introduce for smaller applications where up to now, the before mentioned SICAM A8000, CP8000, 21 and 22 LTUs fitted perfectly, a corresponding new small LTU, and this will be, of course, be part of our SICAM 8 platform. On our roadmap for new members of the platform, hardware-wise are the CP8010 and CP8012. They will cover not only the functions you know from the smaller SICAM 8000 LTUs, but will have additionally all the features of the SICAM 8 platform, like, for example, the enhanced cybersecurity functions and, of course, much more. The CP8012 will also come similar to the CP8022 with a LTE communication and GPRS backup. But all the new CP81X LTUs are modular and can also equipped optionally with a small snap-in display. Stay tuned. We will inform you as soon as this beautiful new SICAM 8 and SICAM 8000 LTUs will be released. The planned release date is mid of next calendar year. Let me come now to the Linux-based 8000 LTUs. And of course, they are base and fundamental and part of the SICAM 8 platform. The basic hardware modularity concept is identical to what we just saw for the smaller 8000 LTUs. Here you can see again this basic concept. But what is different, or better, what additional features are possible with the CP8050? Of course, the first difference is the operating system, what is an embedded Linux. The processor power and available memory of the CP8050 is much more powerful. And also the number of communication interfaces directly available on the CP8050 is identical to what you saw earlier. 4 communication interfaces, 2 Ethernet-based and 2 serial-based interfaces. But different is that you can equip these interfaces with up to 8 protocols, meaning that you can have different Ethernet-based protocols running on one physical Ethernet interface. There are also some additional input-output modules available to be used together with the Linux-based A8000 LTUs. On the one hand, a secure command-output module, the DO8221. And if you, in case you need more, but not so high secure outputs, a transistor-based digital output module, the DO8230. And another type of analog input modules, the analog input module 8330 and 40, where you can also have direct connection to current and voltage transformers, but coming with a much higher accuracy and additionally with the possibility to have a synchrocheck functionality integrated. But of course, there are much more differences regards hardware modularity, communication possibilities, and applications. Let's have a deeper look. The CP8050 can be set up in a redundant architecture. The smaller ones, no chance, it's not possible. I mentioned at the last slide that the CP8050 can be equipped with up to 8 protocols, but this number can be increased up to 24 protocols. How can you do this? Simple, by using the so-called extended processing license, what installs up to 4 virtual CPUs onto the CP8050. And each virtual CPU is providing the possibility to load up to 4 additional protocols and 1 additional independent PLC instance. The virtual CPU, or better the extended processing license, can also be used for the so-called rack solution, for connecting 19-inch SICAM EK3 racks to a CP8050. More about that will come in one of the next slides. And you can separate your network connection by using the application layer firewall functionality, Another way, a separation using virtual LAN technology or functionality is also possible with the Linux-based RTUs. And additionally, you have the possibility to provide up to 3 protected runtime container for installing your own application. And we covered this in our CEP webinar, what was also part of this SICAM 8 series. Let us now see what additional benefits and extended possibilities regarding the number of connected input-output modules and the number of physical communication interfaces are possible with our beautiful CP8050. In the small RTUs, you can only equip the basic line with input-output modules. For the CP8050, it is possible to connect up to 15 additional lines containing I/O modules. They are called remote I/O lines. The connection is done via an Ethernet-based input-output bus, what can be from the architecture, either in a daisy chain or in a ring configuration, what is providing a high availability. The external lines are having a communication interface, CI853X, for establishing the connection to the CP8050 and between the remote I/O lines. These modules are coming with integrated power supply for the I/O modules and can either be equipped with electrical or fiber optical interfaces. But not only the number of connected I/O lines, meaning the number of I/O modules what can be used with the CP8050 can be increased. Also for communication to connected IEDs, often called southbound connections, and to higher level control centers, often called northbound connections, you have additional communication interface modules what can be connected to the CP8050 CPU. For Ethernet-based protocol, you can equip up to 2 CI85-2X modules, each coming with 5 physical Ethernet ports. And you can select between CI8520 with 5 electrical RJ45 interfaces and CI8522 with 2 fiber optic interfaces and 3 RJ45 electrical interfaces. These communication modules are supporting, of course, the Ethernet-based redundancy protocols like line redundancy, also called dual homing, RSTP, rapid spanning tree protocol, PRP, parallel redundancy protocol, and HSR, high seamless redundancy protocol. But also for serial protocols, it is also possible to connect up to 6 CI8551 communication modules, each providing 5 serial interfaces. When you equip the CP8050 with 1 Ethernet communication module, you can add up to 5 serial communication modules additionally. In case you need 2 Ethernet extension communication modules, then it is not allowed to add additional serial communication modules. The last important difference, the topic of enhanced cybersecurity functioning of the Linux-based RTUs, I will not mention in today's webinar. That has been covered in several webinars from my colleague Georg Marke, is the possibility to provide a web-based HMI functionality with the Linux-based SICAM A8000 RTUs. Okay, coming now to the CP8031, also Linux-based and therefore part of the SICAM 8 platform. After CP8031 is using very similar powerful processor and memory features. Most of the functions I introduced for the CP8050 are also possible. Therefore, I will focus only on the differences. Redundant RTU controllers are not supported with the CP8081. The CP8031 allows to load up to 4 protocols and not like the CP8058. And as it is not possible to equip this extended processing license on the CP8031, also the rack solution is not supported. And it's not possible to load additional protocols. And only 1 runtime container for 1 CApp application is allowed instead of the 3 what the CP8050 is having. It is, or better it was, not possible to connect additional remote I/O lines or additional communication modules. Only input-output modules in the main line and the communication interface of the CPU itself were possible. Now, via a new license, what is called CP8031 Extended CI, Communication Interface Module, it's now possible to have one additional external input-output line and one additional communication module. And this could be either an Ethernet-based or serial-based communication extension module. For the CP8050, I mentioned the rack solution. Let's have now a short look into this concept. For projects using our SICAM AK or SICAM AK3 19-inch based large LTUs, what needs to be migrated to the latest cybersecurity requirements, or for projects where a higher density for the input outputs per I/O module is needed, or it's the 19-inch technology is required, the rack solution provides a perfect solution. What is needed for this solution? Per SICAM AK3 rack, you need one extended processing license. We call it also virtual CPU. That is identical to the old SICAM AK3 concept, where an additional rack is connected via an own physical CPU. Now we are using a virtual CPU. The CPU of an existing SICAM AK3 rack needs to be exchanged with a communication interface module CI2530. That is all. And you can install up to 4 times this extended processing license into a CP8050. That means up to 4 racks can be connected. And a mixture with SICAM A8000 remote I/O lines is of course possible. And one rack is counting like 4 remote lines. So in total 16, you can make the calculation by your own. Of course, also redundant CP8050 CPUs are also supporting the rack solution. But not only for migration of our legacy SICAM AK, AK3 projects, enabling our customer to keep as much of their investment saved in reusing hardware components and bringing the project to the latest state of functionality and latest state of cybersecurity, but also for other legacy RTU components, we can provide a concept. I'm talking about the reuse of our SICAM TM input-output modules. They can also be connected to our modern SICAM A8000 RTUs via coupling modules to the entire range. That is also possible for remote I/O lines for the CP8050 or CP8031. Only within one line, it's not allowed to have a mixture between new SICAM A8000 input-output modules and old SICAM TM modules. But in one line, you can have one type of modules, and for the RTUs with more lines, one can be equipped with new modules and one with old modules. Okay. With the introduction and the release of the new SICAM 8 Power Automation platform, we also introduced a new way for licensing special functions but are not coming with a basic functionality. That was or is the SICAM Function Point Manager. I demonstrated in our last webinar the workflow for this new way of licensing and will therefore today not going into detail again. What can be said is that for the SICAM A8000, the licenses what existed before the release of the SICAM 8 platform still can be ordered as ALM licenses via online software delivery and handled as before. But additionally, it is also possible to use the new workflow with the SICAM Function Point Manager. Even a mixture of both ways within one CP8050 or CP8031 is possible. Also new licenses, what has been released together with the SICAM 8 platform, like for example the SICAM HMI, or will be released from now on, they are only available via license created with the license SICAM Function Point Manager. What else is new for the SICAM A8000 RTUs? In this slide, you can see all the security features coming with the SICAM 8 platform. They are, of course, implemented in our Linux-based SICAM 8000 RTUs, and most of them also in the small, not Linux-based members of the SICAM 8000 family. As there are very detailed webinars explaining all the cybersecurity function in detail from our colleague Georg Merkel, I will not go into detail, but mention only 3 newly implemented features, and for one of them I will spend some more words. In case you missed the webinar from Georg, you still can register and watch the recording. At the end of this webinar, we will show you the links and the QR code for registering. Here you can see a summary of new functions for our SICAM A8000 RTUs. The orange marks are related to cybersecurity. The others are related to new communication-related improvements, and I will come back in some minutes to these new functions. Cybersecurity-related new functions are the support of the connection to a secure LDAP authentication server, additionally to radius and normal LDAP authentication server, what have been supported already earlier. Second one, when connecting an IED to a network device like a switch, it's also a cybersecurity feature and requirement to reject the communication of the IED using this network in case the IED is not authenticated via an authentication server. That functionality is handled by the IEEE 802.1x standard. The Linux-based SICAM A8000 RTUs can manage this authentication for protection devices connected to the CP8050 towards the central server. And it is not necessary that each protection device is doing that on its own. The next cybersecurity-related new function is a new advanced intrusion detection functionality integrated in our Linux-based A8000 RTUs. In our standard security blueprint for a secure substation, this function is running, for example, on a dedicated router with next generation firewall and in the integrated intrusion detection functionality. As not all customers are already investing in the 100% solution for a secure substation, or depending on the project size and the importance of the substation, a basic setup for security is sufficient. And this feature provides now a very good alternative for such use cases. What is the purpose of such an intrusion detection system? It helps to find out if there is an attack at all. It has to detect an attack, but is not able to stop, for example, malicious traffic. However, the detection and logging of suspicious activities helps the experts to analyze anomalies, to identify the source of the attack much better. First of all security relevant information, not only communication-related topics, but also physical or operational information like access to a control room, for example, via door contact, must be security locked and protected against manipulation, and then forwarded via syslog protocol to a central logging server, where the expert can access the information for evaluation and analysis. The main purpose of the new intrusion detection and syslog functionality is to allow the user or the expert to have a better understanding of attacks on our RTUs. How can this be achieved? With the enhancement of the cybersecurity features integrated into our CP8050 RTUs, providing now advanced detection and advanced logging features, what allows detailed analysis after an incident. Communication-related attacks like ARP or TCP sync flute denial out of service can be detected and logged, but not blocked. Also, traffic blocked via our whitelist filter is detected and logged for later evaluation. But not only communication-related information can be relevant for the security of a substation. Therefore, also process-related information like switching a breaker or physical access to the control room at times where the station is unmanned can be detected and put into the security log file. The advanced logging features are not only helping to secure the information stored in the security log file, but also to avoid an overflow of the buffer by using a counter to stop adding entries for the same attack and to give false positive where there was in reality no attack at all. Like promised, I'm coming now back to the new communication-related improvements implemented in our Linux-based SICAM A8000 RTUs. The first communication-related news refers to the IEC 6150 server implementation. The actual latest edition 2.1 is supported additionally to the edition 2. That includes also some new logical nodes defined in the IEC 650 part 90-2. This part takes care about communication between substation and control centers. And in the part 7-420, that part is defining the data model for decentralized energy resources, shortly DER, using IEC 6150 communication. For Ethernet-based protocols, different redundancy algorithms are defined in the standard. Yeah? We know for ring topologies, for example, rapid spanning tree, RSTP, and PRP, ring topology, RSTP and HSR. For network with star topology, line redundancy, also called dual homing, and PRP. In the past, only one pair of the physical interfaces of our communication interface module, CI8520, could be selected for using one of these redundancy algorithms. Now it is possible to define two pairs of interfaces and selecting independently for each pair the redundancy algorithm. Also, separation of networks using the same physical Ethernet interface via virtual LAN technology, shortly VLAN, has been extended to RSTP networks. The next two slides are showing this with example networks architectures. It's now possible to define two physical Ethernet interfaces, each working as a pair, and assign to each pair the needed redundancy algorithm. That could be for both pairs the same. In the slide shown in the first two pictures, 2 times parallel redundancy protocol or 2 times high seamless redundancy protocol, or respectively 2 times rapid spanning tree protocol. But of course, it is also possible to define for each pair different redundancy algorithm shown in the next two pictures. 1 times HSR or RSTP and 1 times PRP, or 1 times PRP and 1 times dual homing, or any other combination. And for the CAPT50, there you can have 2 Ethernet extension communication interface, CI8520 or 22. You can now have up to 4 redundant communication structures. The last keyword was physical communication structures. With our Linux-based SICAM A8000 RTU, you can assign several protocols to one physical interface. Jorge will show it in this presentation. That can be the same protocol, but also different protocols. A separation can be done via virtual LAN, as shown in this slide. That has been already implemented a long time back. New is that can also be used now in RSTP rings. The last new feature I will show you with slides today refers to the so-called single attached nodes, shortly called SEN. I said slides because also after the break, Jorge will demonstrate with our SICAM 8 engineering tool, SICAM Device Manager, the settings of these functions and how easy they can be configured. What is the topic of a single attached node? That is normally used together with so-called seamless redundancy algorithms like parallel redundancy protocol or high seamless redundancy, where inside of the IED with physical redundant interfaces, a piece of software is taking care that no circulating telegrams are blocking the communication and that a double received telegram will be recognized and discarded. IEDs, either with only one physical interface and without this piece of software handling the seamless redundancy, are connected to such networks via a so-called red box, shortly for redundancy box. And this redundancy box is providing the physical redundant network interfaces and the piece of software managing the redundancy. The function of such an external red box is now implemented in our CI85-2022 communication interface. And it is possible to connect the ID or IDs directly to one or to several interfaces, and the CAPT50 will take care to integrate these connected IDs into the PRP or HSR network. Additionally, the integration into RSTP or dual homing networks is also supported. Okay, before we are coming now to the demonstration of Jorge showing you the workflow, we will have a short 5 minutes break. And after this break, I will call Jorge at stage. And I'm already very excited to see how easy the engineering of our CP8050 is and seeing the features I introduced, how they are managed and handled by the SICAM Device Manager. See you in 5 minutes.
Welcome back. We will continue now with the second part of our presentation, where I will try to show you what basically new features we have in our latest version of SICAM Device Manager, basically the version 4. We will do this based on an example of one configuration, and some of these things were already presented 1.5 years ago in a previous WebTQ. So we will be focused more on the new features. So let's go straight to the work at hand. Here is what I prepared today. We will see how we can create a project with the new SICAM Device Manager version 4, how you can configure the hardware of your RTU, how you can define your communication interfaces, how you can define the firmware for the communication. I will also clarify or explain some of the basic system settings that you need to take care of. I will show you where you can set some of the security features in the CP8050. I will also show you some of the features available in the firewall application. Of course, we will see what is new regarding RTU signals configuration, and also some nice new features available in the CFC editor. So let's start, and let's check out the example that we have for the implementation today. So we can assume we have a couple of bays belonging to a station with 2 bays. We have there also at least one CProtect device equipped with the 62050 communication protocol. We have a control center which will receive information from this station via the IC104 communication protocol. To demonstrate how easy we can also integrate different control centers also with different communication protocols, we will assume we have another control center that will be connected with the RTU via DMP3 or TCP/IP. As a time reference server, we will have an NTP server in the system. And there we have one CP8050 RTU with some modules already predefined, which will be the core of the system that we will configure. So you can see how you can implement an external row in the RTU. I will show you how you can add one of these rows, how it will be connected with the API pass in the CP8050. We will also see how we can implement one external 19-inch rack, and how we can connect it to our EBI line, and also how we can configure it as a redundant ring. To see how we can implement signals in the system, we will do it by assuming that these signals from the Bay 2 are coming via conventional wiring to binary inputs and outputs in our A8000. We will assume we will have an engineering PC, and it will be connected to a specific LAN. We will call it conf LAN. So we will have an IP address in this LAN. We will also assume we will have a redundant network connection, RSTP. So the CProtect devices will be connected through that connection, where we will have also a known IP address in the RTU. And the RTU will act as an NTP server for the CProtect devices. We will have also, through this single port in the CP8050, one connection with the control center via 104. So we have one IP address for this connection. And through this connection, we will also get the time reference from this NTP server with a predefined IP address. And to demonstrate how we can, through the same port, have different communication protocols, we will have here a DMP LAN with one own IP address, and this will be connected with this control center. This, just to finalize this example, we will show you how to configure this new feature, the red box functionality. So this CProtect will be connected here, DXC4, CProtect 4 connection, which doesn't have RSTP, but through this port we will have it connected via 6150 also, and also sharing all information with the devices in this network. So basically, this is a full example that we will try to configure. So let's start how you can create the project. Once you open SICAM Device Manager for the first time, you will get a blank, so no project is open, and SICAM Device Manager will give you a hint what steps you can follow. So it will tell you that you can create a new project by going to this menu. Go Project, Create. Then you can give a project name. You can assign a path where the project will be stored. And then something new from version 3.9, you will be asked about an encryption wallet. So basically, what is this? Why do we have a wallet? When you have a SICAM Device Manager configuration in an RTU, there are a lot of so-called security parameters. What is a security parameter? You can find out which are security parameters in SICAM Device Manager because normally they are not displayed freely, but instead they are shown with asterisks like this. This is a key, for example, that you need to enter to activate an encrypted service. There are a lot of such parameters in the configuration. So these parameters from the version 3.9 must be also encrypted inside of SICAM Device Manager. So there must be a key to encrypt them. And this key is stored in a wallet. So only if you have the wallet, the signal, the encryption of these passwords have been stored, then you will be able to retrieve these parameters in your configuration. If in your configuration you are not using any of these parameters, then actually the use of the wallet will be a little bit irrelevant. But if you are using these parameters, then you need to store your wallet, so you will be able to retrieve your configuration and the passwords. So all these security parameters will be stored there. This is basically the reason why we have this wallet. In any case, regardless of if we need them or not in our configuration, we need to define an encryption wallet. So how you can define or create an encryption wallet? So to create one from scratch, we just assign here plus. We can create maybe a new folder to store it, my wallet, and then I can just scroll there, and here I can create my wallet. I must define a password for it, and I must confirm it. Now it has been defined, and I can finish with the creation of the project. Now, the Device Manager also gives me hints what I can do next. I can now, inside of this project, create a structure with folders, maybe to start the RTUs that I have there in a more organized way. So I will create with this button a new folder, and maybe I can call it like Region North. Why not? And then I can just browse into this region, this folder. And here I can either create new folders or I can go straight to create a new device. With this button, we can create a new device. So I click here, and then I get this dialog. I must define a device name. It must be unique within your project. Then I need to define the device type. So the device type in this case would be a CP8050. Next, we have the engineering address. The engineering address is the IP address that SICAM Device Manager will use to try to access the device when I try to load it or to monitor or whatever. This address is not stored in the device. This is just information for SICAM Device Manager to try to access the device. The one that we are seeing here is the default address that we have in a new CP8050. So it makes sense to leave it for the time being. Then we need to define a region and component number. the rule is the combination of region and component number must be unique within a SICAM Device Manager project. And we define also a common ASDO 1 and 2. This common ASDO will be used when we generate new signals in this RTU, in this system. They will be assigned automatically this common ASDO combination. Of course, it could be changed later individually for each signal. I can confirm, and then I have already a container where all the configuration of this RTU will be stored. So now that we finish this first part of the project, we can proceed with the next step, which would be to configure the hardware of the RTU. This means we want to create this, the base device where the CP8050 is located, and the external row, and the rack, and the connections. So how can this be done? It also includes several steps. So let's go to the first one. How to equip the CPU in the RTU. So we have here the container that we just created. I will proceed, and then we have this hardware box. We go there, and there we will see that we are on the base device. Base device is basically the location where the main CPU, the CP8050, will be located. And here I have a add button that I will use to add my different models. So I will add here, new module, CP8050, and confirm. Then automatically, the Device Manager will equip the CPU with firmware for different applications. The first application, the RTU functionality of the RTU, which allows me to have communication protocols, for example, and also the version. I can select which version I want to have here. Another for SICAM Web. So yeah, I can configure and monitor the RTU, and another for the inputs and outputs located in the same row where the CP8050 is located. As mentioned, I can change here the version. If I want, I can equip it with older versions. I don't have to use the latest one. The key here, anyway, is that if I have one version equipped, I cannot go back to another version. I can always upgrade to a newer one, but I cannot go to another one. So then I can confirm, and the CP8050 has been already equipped in the configuration. This is the first step. Next step, let's configure the other devices, the other modules that are attached to the CP8050. This is what we call the base device. It's basically this group that is displayed with this square. So you will see here, we are on the base device, and on the CP8050, I have one button, one add button to the right. Here is where I add power supply modules and also input-output modules. So I click here, add, and then I can see behind the scenes, darkened here, the CP8050, and I can select here first one power supply that I want to equip, maybe this one, and I can equip it by clicking on this button. Then I can see that it has been actually equipped. I could equip even a second power supply. It is allowed. We will not do it in this case, but it could be done. We now want to add one digital input module. So one, I can see it behind. I want to have a second one. And then I want to have a binary output module. I can add up to 8 modules here. But now I'm happy with what I have, so I just close this. So the next step is to add the communication interface extensions. They are connected to the left. So for that, I click the Add button to the left of the CP8050. And I select the module and confirm. I could add even another module, but I will just close. I'm happy with that. And then we are ready with the configuration of the base device, at least with the equipping of the hardware. Now, let's see how we can add the external rows. We are talking about this row that is displayed here. The first thing that we need to do is to add an I/O bus to the base device. How do we do that? We use this button. So it is included here, and by default, it is connected to the CP8050 to the port X2. If we are having external periphery or external rows in a CP8050, the port of the CPU, the port X2, must be used to connect this periphery. This port then is not available for other communication protocols. I can also use the X3 if I want to use a ring. At the moment, it is not available. This is why it's displayed like that. I can live with that for the moment. I will leave it like that. And then we will proceed by adding the I/O rows now to this I/O bus line. So for that, I will go to this button here, Add I/O. Then here I'm offered Add I/O row, and I must select here which is the row number. I can have up to 15 external rows connected to a CP8050. So I can select here which one will this one, 1 to 15. So let's select the 1. And then which type of communication interface connection I need for this master module, for this row. There are 4 different types, depending on the power supply that they will provide, and depending on if they will be equipped with fiber optic or with electrical port. So I select the first one in this case, and I'm happy with the selection. I just confirm. Then Device Manager offers me the possibility to select the firmware for the inputs and outputs that will be connected to this line. I could select this one, which is the one for a standard A8000 input-output modules, or I could select a different one for connection of the old legacy TM modules, which can be also connected here. So I will live with this. I could select also the version if I wanted, and I just confirm. I can see now that I have this module here depicted as for the row 1, which also acts as a power supply for the group. I need to add now to the right of this module either a redundant power supply or the input and output modules. So add here. I could add another power supply if I wanted to, or I can go to the I/O modules and I can add another digital input module, for example, and confirm. Then I can see it here. I'm happy, close, done. So far, so good, everything easy. Now let's see how we could insert a external 19-inch rack. We're talking about this that we are seeing here. It should also be connected in a redundant ring here. So to add the external rack, we proceed exactly in the same way as we added this row. We need to go back to the I/O bus line. And from there, we must add I/O, this button. And now we don't want to add another standard row. We want to add a rack. Now, remember, Michael told us that to connect one rack, you need to have a virtual CPU in the CP8050, which is nothing but the extended processing license that must be loaded in the RTU. So we need to equip first this extended processing license. So for that, we press on this button, plus. We can have up to 4 different virtual CPUs or extended processing. So here I select which one I want to use. Let's keep the C1. I can also keep the latest version of firmware available and confirm. And then now that I have this extended processing, this virtual CPU, I can select which type of rack I want to include. Basically, there is the possibility to include the CM2844 with 9 or 8 slots, or the CM2846 with 17 slots. Basically, these first two are used for legacy RTUs that are being migrated maybe to CP8050 from AK3 to CP8050. They are not sold anymore for new projects. There is only this module available. So we select this one, and then we confirm, and then we are already brought that to this first rack, where we can see it is already equipped with the module CI2530, which allows us to connect the rack with the ring to this I/O bus. We need to add now the power supply of this rack, which could be also redundant. So to add each one, we just use this button. It's quite intuitive, actually. So we click here, and then we can select which type of power supply we want to equip and confirm, and there we have it. To add one module in one slot, same procedure. Click here. I select the module I want to have and confirm. The firmware that will be equipped is offered. I confirm, and I have it here. And there is also, actually with a lot of modules, there is the possibility to exchange it. So select the module individually, and you go to this button, and then you can exchange it with a module of the similar characteristics. Maybe I wanted to have a different voltage for the inputs. Then I can change it without having to remove anything. So far, we are basically done with the configuration of the hardware. We need now to configure the communication ports in the RTU. So let's start by configuring the communication ports in the CP8050 module itself. So basically, in this case, in our configuration, these two LAN ports should be used to have this as a ring. Okay, this is important. And the serial ports in this case are not being used, but anyway, they are available. So in order to configure this module, these communication ports, we go back to the base device. And then we select the CPU, the CP8050. And then we go to the settings. And in the settings, I can see that the I/O bus is connected as a line because the port X3 is not free since it is being used for this port, singular connection. So I need to free this one, to release this one, so it can be, the port X3 can be used here. How can I do it? I come here and select the blank space. Then I get a warning indicating me that this port is already being used by a so-called LAN 1. This was a LAN that was created by default when we created the RTU. This is used for configuration. So system is making me aware that there is something that will no longer be correct. I take the risk. And then here I can switch this from line to ring, and then both ports X2 and X3 are properly configured. I have my ring completely configured. In addition to that, if I scroll down, I could see that there are some properties for the serial ports. For example, I could enable or disable the terminal resistor for the RS485 port CPX4. So there are additional settings that you can do always in these settings. I just confirm. And now let's see how you can configure the ports of the extension module CI8520. We are talking about this module here. So in this example, we are configuring the ports 1 and 2 for RSTP, so we can connect the Ciprotec devices via 62050. We are using the port X3 for configuration, singular connection. We are using the port X4 for a red box connection with this one, so we will be like having a Ciprotec 4 device connected in this RSTP network. And we have the port X5 used for two different communication protocols, IC104 and DMP3. So this is what we have here. So How do we do it? First, in base device, we go to the CA8520, and then we go to the settings. And then we start first, select here, RSTP. I'm using the port X1 and X2 for that. Then, next line, I select a singular connection connected to X3, which will be used for configuration. Then I will add the X5 connection, so we can use it for DMP3 and 104. So here, select singular, and then I can freely do this. And I can add another one for this red box functionality. So singular, which is mapped automatically to the X4. Now, in addition to this definition, I can see some parameters additional for this redundant connection, RSTP in this case. And if I scroll down, I will see more. I will see, for example, this red box functionality, which we want to use in this case. We want to bridge the X4 port with the X1 and 2. So I will add here the red box, one row, and I will bridge the RSTP ports with the X4. So what are we achieving with that? Why we have this red box functionality? So basically, remember, we have a Ciprotec 5 network here, where they are exchanging goods messages, for example, communication, and it's connected here. And the Ciprotec device does not, the Ciprotec 4 does not have RSTP directly. And maybe we don't have any switch where we can connect it there. So we can connect it here. And through this functionality, we can bridge this communication. And it will be exactly as having it connected to the same network. Remember, for this functionality, you need a license, a Redbox license. You can use one of these licenses in one RTU only. If you want to use it as a demo, then you have 21 days for that. These are the types of combinations you can have, so you can match any of these types of redundant network with networks of these types. So now that we have done this, we can just try to save the configuration. We can see this red symbol here, the pencil indicating that there are unsaved changes in the configuration. So if I save it, then I get, in this case, a warning indicating me that there is inconsistent data found. So I confirm, and I can see that now here I have a message log, which is shown with red color, indicating that there is something there for me. If I click there, I can see exactly what was wrong in my configuration. It is telling me that there is a LAN 1 interface which has been left orphan of a physical port. Okay, so I'm aware of that. I go back. I must keep this in mind. And then I will go back. I'm ready with the hardware. And now I can proceed with the next part, which would be the configuration of the communication. In the communication settings of the RTU, basically, we have also different parts. So let's start with the configuration of the LAN interfaces. We will have a LAN for configuration. We will have a LAN for 650 communication. We will have a LAN for IC104 communication, and we will have a LAN for the MP3 communication. So to go to the communication settings, we go back home in the SICAM Device Manager, and we go to the communication box. In the communication box, we will have under LAN interface, we will see that there is already this already mentioned LAN 1. And we see this pink color indicating that there is something missing in the configuration because this is orphan of a port. I want to use the port X3 in the CI85 20, this one. So I select it. Sorry, for the communication, for the configuration, the port X3. So we map it here, and then this is the IP address, perfect. We want to configure it still under this address, perfect. Maybe it is interesting, if this is the port, the LAN that is used for configuration, I should have a name that is more suggesting of the functionality. So maybe we can just rename it to config LAN. Now we can create the other LANs that we need. How do we add more LANs? Through this plus button. So we add here plus, and then we have here 61850 LAN, which will be using this RSTP combination, perfect. I select the IP address that this LAN will use in the RTU. Another LAN, which we will use for IC104 connection, which will go through the port X5, and I select the IP address. And now still one for the MP3, the MP LAN. I will use the same port as the one used for 104. And I set a different IP address. So you can see how in the same hardware port, LAN port, I can have two different IP addresses, and I can have two different communication protocols running without any problem. So that's basically it. This is how you define your LAN interfaces. So now, in the configuration communication box, we can also set the serial interfaces. For this current example, we don't have any serial protocol, but we still have the two serial ports. So in the CP8050. So in this case, anyway, if you go to serial interfaces, you will see the two ports of the CP8050 available. So basically, if we had additional modules with additional LAN ports, we could add them here and list them and have them available later for the communication protocols. Now we have configuration of client services. This means services where the A8000 is receiving a service information. What is the most basic example of that? The A8000 will receive, in this example, the time synchronization from an NTP server. So it will be an NTP client. So in this case, the NTP server is defined here. And I have here, for example, the panic threshold. This is just a tip that I give for configuration. This panic threshold is a standard NTP parameter. And if the RTU has an internal time that is different from the time provided by an NTP server by more than this value, the RTU considers, the NTP daemon that is running on the CP8050 considers that there is something really wrong with the time source, and then it switches off, shut down the whole NTP service, and then it will not be time synchronized. So at least for the commissioning, for the first time where you are loading it, one way to get around this problem is to set this panic threshold to 0. And in this case, this checking is disabled. Then when it is connected with the NTP server, it will get synchronized, and then you can change it back to 15 minutes if you want to, or you can leave it in 0. Now, we need to define also through which interface the RTU will get the time, will get in touch with the NTP server. So we do this through this assign LAN interfaces. It's empty now. We will add here. And we can select, in this example, we want to get the time synchronization, the NTP service from the 104 LAN. So we select here IC104 LAN. And here we define the IP address of the NTP server that is connected through this path. We can add in total up to 4 different NTP servers for that. And the configuration is as simple as that. There are other services in this case, like synchronization via PTP. Also, you can configure through menu here, scrolling down. And last but not least, regarding these communication settings, we have also server services. So in this case, you can go here to server services, and here again we have NTP. We said that we wanted the RTU should be the NTP server for the time to be provided to the CProtect devices via 62050. So we can do it. We can define, we want to be NTP servers through this LAN here, the 650 LAN. And with that, that's all. The RTU would provide the NTP service to the devices on this LAN. Quite easy to configure. There is also another server service that is quite important, as is the engineering interface, SICAM web. By default, when you create a new RTU, there is a LAN 1 created, which we just renamed to config LAN, if you remember, some minutes ago. And this has been already assigned here in LAN interfaces under engineering interface. This means we can configure the RTU and monitor the RTU through this interface. If I want to be able to monitor the RTU also through other interfaces, I just need to add them here and list them here. And as easy, as simple as that, it could be done. Okay, so now that we are done with this, then we can proceed with the next part, which is how we can equip the firmware for the different communication protocols. Because so far we have defined the LANs, but not the communication protocols themselves. So let's go here in application configuration. For the current example, we are talking about 3 different communication protocols. We have IEC104, we have DMP3, and we have 62050. So we need to equip these 3 protocol elements in our configuration. To do that, we go back to home in the configuration, and then we go to the box application configuration and licensing. And here, RTU, we go to S8000 RTU master, protocols and IOs. And here I have the space where I can add up to 8 communication protocols, to 8 protocol elements. How do I add one? I want to add one for 104. So I click here on the plus. I get this window where I can select the communication protocol I want to add, ETI4 for IEC104, and I confirm. So this has been equipped here, but I want this protocol to run under a specific LAN, the LAN for 104, so I can select it here. IEC104 LAN. So this was the protocol element 0. Let's add a new one for the MP3 slave plus protocol 1, the MP3 TCP IP slave, confirm, and then I select the LAN, the interface. And now we will do it for 62050. So protocol 2 for ETI5, 62050, confirm, and I assign it to 62050 LAN. And that's it. With this, we have configured or equipped the protocol, the firmware of the different communication protocols into our RTU. Now let's see some system settings we have in our RTU. You access them through this box, system settings. And basically, this is important to define in which time zone our RTU will be running. As you know, the NTP synchronization, for example, is always performed UTC, but you want to have a local time reference in the RTU, so it needs to know how it has to correct this UTC time. So this you can set here. Here, with this parameter, synchronizing of the device, you can also define if the RTU will have its time synchronized via an external source like NTP, or if it should run with internal time only. So you have to set it manually via SICAM web. You define it Here, it will be the pre-running, the name of the setting. There are more parameters that you can get by scrolling down here. Like, for example, if you want the time synchronization to run via IRIC-B, then you need to enable it here. Or also, if there are some changes later in the policy in the European Union or in your region, whatever, where a different rule for summer, winter time switchover, then you can define it here. So we are also prepared for changes in policies in the future. Now, let's take a look at some security settings we have in the RTU. Just an overview where you can set these parameters, because a deep view of the parameters and the meanings, actually there are, as Michael mentioned, some other webinars that focus exclusively and very deep in this kind of configuration. The security parameters and services are defined under the security box in the configuration. So once you scroll there, you will see here, you can browse through them, and I will mention just some of the most important. We have this remote security logging. So as mentioned, we have a security log, a syslog running internally in the RTU. So all the security relevant events are stored in non-volatile memory in the RTU. But they can also be transferred to an external syslog server. And here you can define how this would be connected. Okay, also, it could also be redundant. This is where you perform this definition. We have also role-based access control. Actually, the access to the RTU is always under role-based access control, only username and password. The question is, how do you define the users and passwords? Every RTU has a local user management. You can define on the RTU directly local users, and there the passwords can be defined. The passwords are not defined in SICAM Device Manager. The only thing that is defined for this local administration is the password policy, like after how many attempts during a specific time, wrong attempts could be done. If this happens, then this user will be blocked for that time. Or also the password complexity. You can define it here for local user management. But you may want to use some external centralized user management, like Windows Active Directory, for example. In this case, you can connect the RTU directly to one of these systems via LDAPs or via a radius. And you set these parameters here. Now, some other interesting parameters here under device settings. You can define the SD card mode, which means if you want the spare part concept, which means that you should be able to replace the RTU without having to use the configuration tool like SICAM Device Manager by just having an SD card with the configuration of the RTU. You insert it in a new one and then it runs. Then you need to have this parameter active in the configuration. You can disable it. In this case, you cannot replace it simple. You need to load it with this also. It will be maybe safer, but it will be not so comfortable to replace. You can also enable the use of scalable vector graphics for the dashboards in the configuration. You need to enable here. The security log can also be deactivated here. By default, it is activated, but you can deactivate it here. And so, okay, so basically this was a small overview of some of the important parameters in this security. Now let's take a look at the firewall. When we configure one CP8050, even if we are unaware, we are configuring a firewall where only certain ports and services are being enabled for specific interfaces. So you can check that by going to this firewall box. For example, in this case, we configure this config LAN that is assigned to this port that has this IP address to enable configuration for the engineering web. This means it enables automatically the HTTPS server service to the port 443. We can, at the moment, by default, it is assigned to or allowed to any IP address. This is why we have 000 here. But we could narrow it even more, and we can define only this specific IP address should have right to access the configuration. So you can actually make it quite secure if you want. Also, for the different communication protocols, there you can see that you can narrow the access of the service. We have also here the possibility to allow the discovery of the different interfaces, the LANs that we created via pinging. By default, when the RTU is created, the LAN 1, now called config LAN, can be pinged. This is why there is this entry here. But we can also make the other LANs that we have created discoverable in this way by just adding them here. Just clicking here, and I'm selecting the new LAN, and then I can ping this one. And I can do also for the other ones quite easily. This is very simple, and at least for commissioning, this is a great help for you. Now, scrolling down, you will find another very nice feature, which is called service forwarding. So this is a feature that also is quite helpful, and what it is doing is it provides the possibility to transfer a service from one interface to another. For example, as you can see, this CProtect device is located in a network that is different from the one that is used for configuration. And let's assume that you want to be able to ping this IP address from this device. Normally, you would not be able to do it. But with service forwarding, you can transfer these pinging messages here and backwards. It's quite easy to configure. How do you do it? So we will add here a service forwarding rule. And I can say, okay, I will perform service forwarding from the config LAN to the 61850 LAN. And I can scroll to the right, and I can select, in this case, what I want to transfer is the ICMP service, which is this one that provides the pinging capabilities. And that's it. Just by doing that, it will be possible to ping from the configuration PC to the CProtect devices. Now, let's continue with new things in Device Manager. Let's see how we handle now, in version 4, the signals in the RTU. There is a very change, an important, relevant change from the previous versions up to 3.9 to this one, version 4. This example, we will see how we can create manually our signals in the RTU. And the example we will do based on the configuration of wire signals. So let's assume we have this RTU, and then to this binary input module, we have this mapping of signals, where we have in these different inputs, the position of the different switching devices, Q0, Q1, and Q8 of the bay 2 as double points. And in the next module, binary output module, we will have commands to open and close the circuit breaker and the disconnectors. This will be configured as one-pole double commands. So as the same as previously, all this configuration, the creation of the signals and the assignment of the parameters is performed through the RTU signals box. But now you will find a lot of differences first in the layout of the screen, because now you will find on the left the signal definition area, and on the right the RTU structure. On the previous version, it was all the other way around. In the middle, you still have the signal assignment and parameterization area. So this was the first difference. Now, there is also a second very relevant difference. In this version, now we have signal tree view available, which we can access through this button here. And right now, we can structure our signals in a tree form. For that, we need to add maybe some nodes. Let's add a node here. So through this button, we can add a node. Let's call it, for example, 60 kV as per the voltage level where the signals will be stored. Then I can just select it, and I can add under this level, through this button, a further level, maybe Bay 2. And if I go there, I can add another node, maybe indicating the name of the switching device, the circuit breaker Q0. So I want then, inside of this level, I want to store the signals related to the position and command of the circuit breaker. So to add signals, I will go to this button. I can see this is the path where the signal will be stored, and I can select the name, will be position, and the type is an indication, and as description, maybe I can add the same text as the name. Confirm, then I have the position created there. And I can add now my command in the same way, add. And I will say this is a command, and the type will be command, and the description may be also command, and confirm. So we have now one group where I have created a bunch of related signals. I can now duplicate these signals quite easily. If I have selected it, I can go to this button here, copy. And then after I have copied it, I can go to the node, Bay 2, and I can paste it. I have the Q0, and I want to have now a Q01 and Q08. So I will select now the paste. And the device manager asks me how many copies do I want to have. So I will select 2 copies and confirm. Then I have this dialog box where I say, okay, it's 2 copies, and I want the copies. They will have the text that was the name of the first one, and it will add the value that is here. So I would say, I want the next one to be Q01, so I will put 1. And I want the next one to be Q08, so it will have an increment of 7 to be Q8. And I don't want it to be Q0001. I want to add only 1 0, so I will say number of digits 1, and I confirm. And in this case, you can see that how automatically these signals have been created. So far, the types of the signals and the information object address of the signals has been inserted automatically. If I want to modify this kind of stuff, I need to switch back to the signal list view. How do I do that? By pressing this button. Now, this signal list view is by default collapsed into what is called a view-only mode, which means that actually I cannot see here the information object address, the information type of the signals. I need to be able to switch this to an edition mode. But in order to do that, I need to have access to a symbol that is behind this. So you need to, by hand, expand this area, basically. And you will see here is this button. Actually, I could have let it a little bit to the left, but okay, you can also do it like that. And important is you have access to this button. And with this button, I can switch to the edit view. And now I can see for all my signals, also the common ASDO, information object address, and information type. Please note how in the name there is a slash indicating the limit between the different nodes. This is something to keep in mind, okay? Now, by default, when I created indications, they will be indicated as type 30, which is means single point. But we mentioned that we wanted to create switching devices which are double point positions. So this means I need to change this to be single point, 31. So I can mark them and I can work in bulk here and switch them to double point information and assign it. And I can do the same for the commands and select it double command and map them. But just a hint, this happened because I created first the Q0 and with the position and the command, but I did not edit it first. Had I done it in the beginning, selected it to be double point and double command, then in the duplication, they would have the correct types for the other values, okay? Well, so now we have created the signals, basically, for the two base, and I'm selecting here the commands. I would like to map them to binary outputs. So I go here on the right, and I select the binary output module. And with this button, I can assign it. And then I can select here the indications, and then I select here the indication, the binary input module, and I can assign it. At the moment, I don't see anything because I scroll this too much to the right, so everything is hidden in between. But as in the previous version, there are these small arrows that you can still use to quickly expand the areas. Okay, this button. So now you can see we are in the binary input module, and we can see these three positions that we just inserted. They are all in pink, indicating that there is something missing. This column processing type, I can see a dark arrow indicating that I can select a value there. And this other data point, where it's also pink, but it's in gray and no black arrow, indicating that I don't have any suitable value to add there yet. So first, I will assign these that I can. So I select the whole group and digital input, double point information, and map to them all. And this I need to assign individually, the different positions. Now, if I go here to parameter, I can see additional parameters that I can define for these positions. For example, I can invert individually the open or close binary input. Or going to the right, I can also apply time filters, for example, for the intermediate position or faulty position. So it is not transferred automatically to the control center or HMI when they happen. Now let's see for the commands. If I switch here to the commands, I see nothing here, but it's because we are in the parameter side, and actually under assignment, I should select first which type of processing type I want to apply. So in this case, I select them, and they will be double command, one pole. And I can assign exactly to each one which commands, which contacts will be used. And on the parameter, I can select for the parameters like the duration of the pulse to open, of the pulse to close. Also, the feedback monitoring time for the command of the circuit breaker, maybe 1 second, of the disconnectors, maybe 10 seconds. And also which processing image is the feedback for each one. So basically, this is what is special now in the creation of the signals. Now, the next part is actually some repetition of what we had done before with 650 in the previous system. It's basically the same, but you will see why I want to show this again. We will integrate this device, eProtect, via 61850 to this interface. So you know that we need a configuration file of this device to be loaded in the RTU. So to do that, to import 650 devices, we need to go here to the 650 box. We will get for every protocol element that has been assigned to the 650 communication protocol, we will have two boxes, one client and one server. We want to add some devices as client here, so I press here. And to start importing the file, I go to this box. Then I need to look for the configuration file. Confirm. This will be read. In this case, it's a new device that it was discovered. I mark it. It is, I'm saying it will be imported. This has this IP address, and I select the station number that it will have in my configuration. Could be from 0 to 99. Then I say proceed. At the beginning, it will try to import all of them, all of the signals. I don't need all the signals, so I unmap them all. And then I can select the signals that I want to have in the system. For that, you can use these nice features we have. We can apply filters. The one here is called the fixed filter, where I just type a text like this, CSWI, to indicate switching positions of devices according to 650. And then I have here only signals that have on any column this text. Now I want to narrow it even more. I want to include only signals that have post.stval in this column. So I mark the text and I apply the so-called flash filter, which is this button here. Then I have only these three signals. Perfect. So I mark them all. Then I remove the flash filter. And now I want to have the command. So I mark this text here. The fixed filter remains. I mark this post.ctlval, apply a flash filter. Three commands, I mark them, remove the flash filter. You see that what has been marked before remains. I can now change the filter, fixed filter, to general to find all the trips and pickups in the protection, and I can mark them all. Then I can just change the filter to measurements, and I can apply some clever filters to get all the measurements. You get the idea. When you are done with the selection, you continue. Then you get a summary of all the signals that have been imported, that will be imported, also with some specific address. You could change it here, adapt it if you want, but you can also do it later. So it's much more comfortable to do it later, actually. So continue, then summary, what will be done, confirm, and the signals have been imported. I can check now on the reports that I have these reports imported in the configuration, for example. And if I go back to home and go to RTU settings, I will see that for that protocol element under station definition, one connection for this specific device has been created automatically. I did not have to do it manually. For all other protocols, you need to do it by hand manually, but for 650, just when you import it, it will be done for you, free of errors. Also, in the topology, as we know, for every entry or for every station defined on any protocol element, you need to have a corresponding entry in the topology. This is also done automatically for you. And it is following also our normal rules. You have here the protocol element, the station number, and important is this data flow direction. You know, if the connection, in this connection, the A8000 will be the master, then it must be set to control direction. And if the A8000 will be a slave, then it's monitor direction. In this case, we imported this device. We will be the masters. We will be monitoring this device. So control direction must be set here, done automatically. Now, let's see the signals that were imported. So let's go to RTU signals. So you will see here on their name that the signals were created like this. You can see there is this is the the ID name plus the logical device, and then you have a slash character, and then a name of the signal name. As I mentioned before, remember when we created these nodes in the tree view, when we switched to this view, this was reflected as a slash. So now we imported and this slash came automatically. If we go back to the tree view, you will see that actually a tree topology was also created based on that. So you know it works in both ways. If you have signals that have a slash character, it will be reflected in the tree here. Okay. Now, in this case, this is the organization maybe that is not so good for us. We would like to have these signals from this protection device organized maybe on the voltage level, and then the bay name, and then maybe the name of the protection, something like this. We could organize it by hand like this, moving, cut, paste, but there is also a possibility to do it in a more efficient way by using, for example, Excel. So let's do it. The next part is how you can manage signals, in this case, with Excel. So you need to close all the tabs of your IDs, and then you come here and select signals, and then export. You select Excel file, confirm, then you will be offered all the devices that are stored on this project. You select the ones that you want to export signals from. You say confirm. Then in this case, I'm interested only in exporting signals from 6150 devices. So I select only assign signals and select parameter. So confirm. And then I just leave it to only 6150. And then I say continue. If I wanted to have all the parameters because I wanted to change something else in Excel, maybe I could select all parameters. This will not be relevant for this example, but just to show you, you could do it. And then you export it, and the files will be exported. Now you can open it with Excel, and it will be something like this. You can expand it, and let's see. You have some columns that must be there, but you are free to add your own user-defined columns. So I will add one column here. Okay, insert. And let's call it path. To say like the node structure where I want to store the signals. And maybe I can call it like this, 110 kV, bay 1, and zip for the protection. Okay. Now, maybe I want to add another column here. And I want to use this column actually to define the name that will be imported. So I will just move this text here. This fixed signal name indicates the text that will be imported in Device Manager for the signal. And I will here I use another title, user signal name, and I will just remove here the ID name plus logical device. So I will just leave the signal description, but more general, not so specific of one device. And now here I can use just a simple formula, like this and this, which has a structure more what I want to have in my system. And now I can save this file. And then I have to import it back. So come here, signals, import. Then I select the file. I want to import signals only. And all of these have been detected as modified. So I select them all and confirm. Good, so now if I go to the signals and go to the tree view, I will see that now these old nodes have not been erased, but now they are empty. So I can easily delete them. And if I check on the 110, I will see that the structure as I created it has been created. So this is a very easy way to configure fast your system. Now some changes related to the user-defined dashboard. This feature was also available in the previous version of the Device Manager. There are just some additional features here. So the first feature is that you have additional types of layouts available. Okay, so the list was available before and is still available. It will also be available for the software solution. These graphics dashboards are only available in our RTUs, are still available in the 8000, but will not be available in the software solution. Also the alarms and events, because the SICAM HMI has already another events and alarms. And there is one layout, SICAM HMI, okay, which means this we can use also in this system. There is another WebTLQ for the configuration of SICAM HMI, which already was presented a couple of months ago, I think, and you can always check them, this WebTLQ still. Now, one nice feature that we have at the moment is that we can actually export the tiles that we have here, the dashboards, through this button. So we can export it to a file, and as always, we can open with another tool like Excel, and I can copy it and paste it. And now I can just import it back in Device Manager. And now all could be created automatically, which would save a lot of time. This is a very nice feature. Other than that, we still have the same categories for the configuration of the dashboard: process data message, process data command, process data measurement, and process data set points. Maybe what is new, the configuration is exactly as mentioned in the previous WebTLQs that we have performed related to that. We have for event lists in the dashboard, for alarms. Now we have this additional one, syslog. If you want a specific signal to be stored in the syslog, then there is this parameter. So with that, you can configure this intrusion detection system very user-defined. Archive also, the text, additional text, the status of these statuses of the double point positions, for example. The tile where the signals will be shown. Also the function, if they will be shown as LEDs. Key the position in the tile from 1 to 64, and on the tile, on the box as summary signals, 1 to 3. For commands, basically, we have this similar parameters, only some additional related to the command management. So select execute, timeouts, and also the type of command, short pulse, long pulse, and the function. Also, you can configure now one command to be sent without a dialog, just a click on a button and done. The measurements, you can perform here the scaling of each individual measurement. Also, you can select individually how many decimal places should be shown there. And other than that, are the same as before. And the set points, basically the same as a mixture of what is available for the measurement and for the commands. So now let's go to the last part that we have in the presentation. There are some news regarding the CFC editor. So I will show you how you can create user-defined function blocks quite fast, and this nice feature, automatic CFC generation, which is a really good feature. So this example that we have two bays, bay 1 and bay 2. And let's imagine we want to create one signal to indicate that the bay is closed. Okay, this is a quite straightforward example. So basically, the logic to be created is something like this. We are checking that the circuit breaker is closed and valid, and the disconnected Q1 is closed and valid, and the air switch is open and valid. If this happens, then the signal will be generated. So how do you do it normally? You go to the logic, then you create a CFC chart, and in the CFC chart, you create your gates, the logical gates, and you connect the signals directly here. Straightforward work, nothing new. But we can do it more efficiently if we create user-defined blocks with this function. So how do we create that? So we will go here, we expand here user-defined objects, and we go to new CFC block. We can rename it like user function block, user-defined function block, bay closed. And here we can copy the blocks that we need. We need to define now where the inputs and outputs are coming from. For that, we need to have this part on top. So we can add here in the input with right click, insert one input for the Q0, for example, and we define this is a double point. And we can do it for the Q1 and for the Q8 as well. And we create an output, the bay closed, which will be a single point. And now we can just expand here. We can see now the structure of the double point, and we can just, every element, just drag and drop to the corresponding position. So we can quite easily map these signals here. The same with the output. I expand it here, and the value, I can map it here. So this function block actually has all the logic that we require in this case. So if I go now to my CFC, instead of doing this, the CFC is called now CFC Bay 1. I will just use this user-defined block and drag and drop here. And now in the signals, I just map the Q0 position here, and the Q1 position here, and the Q8 position here, and the bay 1 close position here. And then I can just easily compile, and it's done. So perfectly. I can do it for the second bay as well, the same way. But just imagine that we had maybe 30 bays. Then it would be like a lot of work. So now let's see what we can do with this nice feature, automatic CFC generation. So we have these logics in the RTU. We can export it from here, right-click, export charts. Save. And it will export basically two files. The first one includes the definition of all the connection between the signals and the blocks. And in the second one, there is a definition of the connection between individual blocks. In the configuration that I created here, actually, there is only one user function defined block on the CFC. So there are not internal connections between blocks. So I don't need to take care about this file below. So I just need to take care of the first one. I will open it. And it's something like this. We have here the name of the signal. We have here the address of the signal, common ASDO information object address type. So this is the source, and it is connected to a CFC that is located in the main CPU to the shard with this name. This is the task where the CFC will be created. This is the type of user-defined block that will be used. This is the name of the instance of this block. And then this is the name of the input. Q0 position to the input Q0, Q01 position to the Q1 and Q8, and so on. The other things are not relevant, actually. I can leave them like that. So I can just easily copy this and paste it here. And then I need to adapt it according to the names of the signals that I have. So instead of bay 1, they would be bay 2. In this case, the difference in the address would be in this byte. So I change this byte as well. And the name of the CFC will not be CFC bay 1, but bay 2. And then I can just save this and go to the CFC and then import. Select it. and then the CFC will be created. And if I open it, I will see that it is already properly connected with the bay 2, and it will work. So in this case, I could just do it for 30 bays without problem. If you standardize your functions, you can work quite fast. So basically, with this, we are done with this part of the configuration. Now, Michael will summarize what we have seen today, and then we will be ready for you for questions and answers.
Thank you very much, Jorge. Like always, very impressive to see the intuitive usability of the SICAM Device Manager, showing us to set up our CP8050 configuration from scratch, focusing not only on the new features I highlighted earlier, but also to showing us how easy and straightforward it is to engineer an entire CP8050 project. Before we are coming to the last point of today's agenda and have a look on the burning questions you placed during the session, let me round up the webinar with a short summary, or respectively the points you should remember as takeaway of this webinar. The SICAM A8000 RTUs, or to be more precise, Linux-based CP8050 and CP8031 are building the base and the strong fundament on what we built our SICAM 8 power automation platform. We started more than 10 years back with our CP8000, at that time called CMIC, or Compact Micro RTU. And as of today, we have an installed base of more than 100,000 SICAM A8000 RTUs worldwide. Soon, the CP8021 and CP8022 followed, and then the Linux-based CP8050 joined the SICAM A8000 family in 2017, and the CP8050 in 2021. The SICAM A8000 family basically consists of two branches. The small CP8000, CP8021, CP8022 RTUs using non-Linux as operating system, and therefore are not part of the SICAM A8000, SICAM 8 platform. But on our roadmap, we have already the CP8010, CP8012, what will provide as base the same functionality as the smaller RTUs, and of course a lot more, because they are part of SICAM 8 and can also use all the beautiful features provided by the platform. Looking in the back mirror, the release of the CP8050 coming with an enhanced feature set and a lot of additional functionalities in respect to communication, sizing, redundancy, and of course cybersecurity was a major success factor in the market. With the SICAM A8000 family, we introduced also a new and intuitive engineering tool, the SICAM Device Manager, building also in this aspect the base and the fundament for the SICAM 8 engineering. Coming, of course, now with much more functionality and highly improved usability, easy to learn, and for new SICAM 8 components, providing the same workflow as for the SICAM A8000 RTUs. And that supports our customer to bring their project faster into service. And remember the first slide of this presentation, showing what the market is requiring, need for speed. And that statement is closing the circle of this webinar, meaning now we are done with our presentation for today. Thank you for your attention, and now Jorge join me back on stage for the Q&A session. Okay, let's see what questions came. We overshot our time already by 5 minutes, so we will keep it short, but don't be afraid, all remaining questions will be answered in written form, and you will get this via the email you registered to. Okay, the first one, is there a way to scale down the font in
Device Manager 4 in order to see more signals? I will come back with that. I think so, but I need to revert. I will check.
Okay, good. And last one we will take. It's a new one. What is the difference between SICAM 8 with Linux and software solution? Okay, the software solution is if you install the application, what has been, for example, shown today from Jorge, on an industrial-based PC, what it's having Linux operating system. And the SICAM 8 platform itself, it's based on Linux operating system, either embedded in our A8000 RTUs or installed on a third-party industrial PC. So SICAM 8 is using always Linux as an operating system. And if you install the application on a third-party industrial PC, it's called software solution.
If it is running in a RTU, then it's a 8000.
Yeah, okay. So the last one, can one Ethernet port of CP 8000 series for multiple IP range over multiple protocols? This functionality is only available for the Linux-based RTU on CP8050 and CP8031. The smaller RTUs, CP8000, CP8021, CP8022 are not having this functionality. But the successor, CP8010, 12 will have. Okay, as already mentioned, you will get access to the recording of this event directly after the session via the link you used to log in to just now. And the remaining question we were not able to answer now, all of this we will forward via your register email. So you will have it also later. We hope that we were able to give you a good glimpse on the features and benefits of our SICAM A8000 RTU. And again, they are building the strong fundament of our SICAM 8 power automation platform. We hope to welcome you soon to another webinar. And you can see now, hopefully, the QR code on the screen. And this QR code will lead you to the SICAM 8 webinar series we hinted at earlier. Until then, stay safe, take care, and enjoy the rest of the day. Have a nice day. Cheers. Bye-bye.
Bye-bye.